from main.m to whatever my higher level iOS application is. So we'll never again really need to look at this file. You can't think of any instances in the next few weeks where you'd even want to touch this file. So I'm going to close supporting files altogether and leave us with just 2 files now to glance at. UI application main, it's, sure, C function, yes. Happens to be capitalized, but it's a function, not a method. All right. So when looking at files for the first time, I would generally suggest to start with the .h file, in part because it's simpler, usually shorter, and also because it's often more descriptive. So let's start there. And indeed, it is short. Let's see what's going on. A whole bunch of comments at top. I'm importing the UI kit again so that apparently my class can have access to its functionality. And now we see a similar construct to what you saw with Rob last week, and we recapped a bit ago, at interface, app delegate, UI responder, open bracket, UI application delegate, close bracket. So let's start translating this into slightly less technical English. What does that one line of code do? Yeah? It says it's a child of UI responder. OK, it says what's a child of UI responder? Yeah. OK, it says that the class called appDelegate is a child of UI responder. Good. And what else? And it adheres to the UI application delegate, and I'll scroll to the right to confirm, protocol. So what does that mean? It means not only does it behave much like a UI responder object does. I have no idea what that is, but it sounds like something Apple wrote because it starts with UI, part of UI kit. And UI application delegate is apparently a set of methods that Apple says I have to implement if I implement that protocol. Now this, for the most part, is copy-paste. We won't be so presumptuous as to change these defaults. We'll typically isolate the code that we write else to other files or subsets thereof or to new files of our own. But let's focus on one other detail. Inside of this class definition for the appDelegate class, there's also a property. What was a property? Yeah? Yeah, exactly. It allowed us to synthesize, so to speak, a getter and a setter for ourselves automatically. In other words, to provide programmatic access, functional access to what's typically an individual instance variable. And what's useful about this is that you can specify some attributes for those setters and getters. And we'll see this in more detail before long. But non-atomic just means, hey, Xcode, when you generate that getter and setter for the property called window, don't bother writing thread-safe code. And by thread-safe, I mean a whole bunch of special synchronization-related code to make sure that only one person can call this function at any given time. The reality is, it's just not going to happen. By convention, this does not need to be atomic code. And by specifying that it should be non-atomic, it makes the getter and or setter faster. So we won't see in the coming weeks really an instance where you need atomic. And technically, it's there just because atomic is the default. And I want my getter and setter to perform ever so slightly faster, even though we humans would never notice. Ah, good question. Are they open source? You can see the header files, the .h files, but to my knowledge, not the actual implementation files, at least not from recent versions of iOS. There may very well be older versions floating around. All we get is the compiled versions of those files and the header files, which are readable. All right. Yes? Can you give us an example of when you would have to use the atomic? If you are writing when would you use atomic as an attribute? If you are writing code that supports multiple threads, so 2 things happening at once, and each of those threads might want to access some value. So let me contrive an example offhand. So iOS now supports printing capabilities. So for instance, if you had some program that allows you to print your notes, for instance, in the Notes application, if the Notes application were multi-threaded, so it could do 2 things at once, and one of those things happened to be printing, and another thing happened to be editing, which surely the Notes application supports, if the printing application, the printing feature, needed to read the contents of your note, the contents of your note might be implemented by way of an instance variable and accessed by way of a getter and setter implemented as a property. Meanwhile, I, the human, with my fingers, might want to actually be editing that same note, and therefore the editing feature might also need to read and or write, get and or set that instance variable through this property. And it's probably not a good thing if I allow both the printing functionality and the editing functionality to look at the value and change that value at the same time, because I might say print now, make some changes, and all of a sudden my printer starts printing out part of the old version and part of the new version, unless I've somehow locked access to that file. So it's contrived in the sense that you can do things so fast that that's not going to happen. And you can make a copy, in theory, of the instance variable and void that problem altogether. But that's the spirit of it. If two things might simultaneously try to read and or write the same value, bad things can happen, like garbled printouts in that case. Yes? Read only. Read only is another. Read only gives you a getter but no setter. Good question. And strong, this one's more easily explained in the future after some number of examples, because it refers to memory management, in particular that automatic reference counting feature that I alluded to earlier. And we'll see this in the context of some GUIs that we actually start programming. So we will revisit. All right, so appdelegate.m is the last place for this program. And recall that this program only loaded a white screen. So all of this effort just to load a white screen, but we'll see in our next example that you can do much more with relatively little additional effort. So this file is a little overwhelming, but thanks to the green lines here, it turns out it's mostly comments. So it's just boilerplate code that Apple provides, and we can actually delete most of this just to simplify. So let me zoom out just to get the lay of the land. On the top of the file, we have some comments. I'm importing appdelegate.h. So appdelegate.m is importing appdelegate.h, common paradigm for the methods file to import the header file. At implementation appdelegate, what does this mean? Translate that one line of code. What's that line of code telling Xcode? Yeah. Exactly. Here comes the implementation of the class called appdelegate, which was declared in the file called appdelegate.h. So this method is hugely named. Application, actually, good opportunity for review. What is the name of this method? Or more precisely, what is the name of the selector? Yes? Good. And as humans, we typically wouldn't say the colons, but it's exactly right. They're part of the name of the method. So application did finish launching with options. So Objective-C, recall, supports essentially some variant of named parameters, where they're not named in the sense that they appear inside of parentheses, as might be common as key-value pairs or as JSON objects in the world of JavaScript programming. But the names of methods in Objective-C are meant in spirit to read like, frankly, full-out sentences. So they do exactly what they say. So what does this one do? I honestly have no idea at first glance. It seems to be code that someone else wrote. Indeed, Apple put it in this template for me. But then there's a few lines of implementation inside of it. Let's take a look here. Self.window gets UI window alloc, init with frame, UI screen maze screen balance. All right, this looks like probably the most complex line of Objective-C code we've seen thus far, but it's really just the combination of very simple building blocks. So someone on the left-hand side, what is self.window referring to? What is that? It's referring to this program's window. And how about more technically underneath the hood? What is self.window, W-I-N-D-O-W, referring to? The view, close. The property. So window, recall, was the name of the property that we saw in what file? Appdelegate.h. So we declared a property called window, and that property was of what type? It was of type UI window, capital UIW window. Okay, and it was a star, which means a pointer there too. So self.window, and again, for those following along at home here with laptops, feel free to download the source code from the course's website so you can toggle back and forth among these files if you would like. So self.window is effectively invoking a method. Which method? The setter. So this is one of these pieces of syntactic sugar that you get with Objective-C. We could implement this same line of code by literally calling setWindow as the setter method that we get automatically by declaring a property. But one of the purposes of properties in Objective-C is just to simplify our code so that we don't have these damn square brackets all over the place and very traditional method calls. It's just so much more readable, just like in JavaScript, to have this dot notation and then an assignment operator, the equal sign, right next to it, which effectively invokes that setter. But it's syntactic sugar in that underneath the hood, this is just a message being passed to an object to set some value. But it reads much more clearly this way. Self.window is going to be assigned what value? All right, so well, someone else, what does this chunk of highlighted code do for us? OK, it allocates a UI window object. I don't really know what that is just yet, but it sounds like something that's useful to have, a window for my application, so I'm allocating